So the first question gives us a table of values of a function f, and it also tells us some important information that this function is continuous. We know that this is a continuous function, and so since the function is continuous, that tells us that not only do we have these dots here that we know points, but there's some sort of continuous function that's connecting all of these dots. And so the question here says, does f of x equal negative 3.1 have a solution? Justify your response. And so as I'm looking through the table of y values of this function, I see 7, negative 0.5, negative 1, 1, 2, 3, and negative 4. And so what I'm seeing here is on this interval here, my y value goes from positive 3 all the way down to negative 4. And so what I'm going to employ here is something called the intermediate value theorem. So I can say, since f of 2 equals 3 and f of 3 equals 4, what does that mean? Well, if I think about it graphically, that's saying that f of 2 is 3 and f of 3 is negative 4. That's here. And then we want to say, so I know that there's going to be some solid line connecting those two. So that's negative 4. And since negative 3.1 is between those y values, 3 and negative 4, the intermediate value theorem states that there must be an x value in the interval 2, 3. So somewhere in between 2 and 3, I'm going to hit this y value negative 3.1. So somewhere in there I'm going to hit that y value because I know my function is continuous, such that f of that x value is equal to negative 3.1. So the short answer is yes, it has a solution. Okay, and then the second question is asking us, what is the minimum number of zeros that f of x must have? And so again, we're going to employ the intermediate value theorem. And so what I'm going to do is I'm going to look up here in my table for intervals that switch signs. So I'm looking for y values on either side of 0. So I go from positive 7 and negative 0.5 on the y values. This one stays negative, but then I go from negative y values back up to positive, and positive, 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 and then I switch back down to negative. So what's happening there is, since my y values are switching from negative to positive or positive to negative, and I know my function is continuous, then it must at some point cross the y-axis, or the x-axis, and make a 0. So what I'm seeing is I'm seeing at minimum number of 3 zeros. So by, again, the intermediate value theorem, there must be zeros in the intervals. Okay, so what are the intervals? So the x equal negative 3 to x equal negative 2. X equal negative 1 to 0, and x equal 2 to 3. So those intervals are all intervals of x values. So if I draw a picture here, I have negative 3 to negative 2, and I know there must be a 0 there because f of negative 3 is 7, which is way up here, and f of negative 2 is 0.5, which is way down here. And so at some point it must cross that axis. right? Because I know my function is, again, continuous. And I can argue the same thing for the other intervals. So for these, we want to compute the derivative. And so we're just going to use the power rule here. So f prime of x is going to be, since the 5 is a constant that's multiplied by a function of x, that 5 is going to stay. And then the derivative of x to the 7th is 7x to the 6th minus, and then the 2, again, since it's a constant that's multiplied by a function of x, that 2 is going to stay there. The derivative of x cubed is 3x squared plus, and the derivative of e to the x is e to the x. For the next one, I'm going to rewrite this before I take the derivative. Because I have that square root there, I'm going to write that as 4x to the 1/2 minus pi x. And again, remember, this pi is a constant, and it's a constant that's being multiplied by a function of x. So we'll kind of keep that in mind. So as I do my dy dx, I'll have the 4 is going to stay because it's a constant that's multiplied by a function of x. Then I'll have 1/2 x to the 1/2 minus 1, which is negative 1/2. Minus, and again, the derivative of pi, since it's multiplied by that x there, the pi is going to stay put, and the derivative of x is 1. And so there's that derivative. For the next one, for the g of t here, since it's this product, I don't quite know how to deal with that yet, so what we're going to do is multiply both of those in, and we'll get g of t is equal to t cubed minus 9t squared. So first we'll simplify this function, and then we will take the derivative. So g prime of t is equal to, again, by the power rule, 3t squared minus, and the 9 is going to stay there, times the derivative of t squared, which is 2t to the first. So